How to live off-grid, Dicky Dread. And today we're covering solar power, still on solar power for off-grid living, and we're on part 5. Fuck, I've just been trying to trim the heads off dock on an 11-acre field. You can imagine how much dock there is. Absolute nightmare in this heat. Can't handle it at all. So it's video time. So we've covered already basic systems, where to get cheap panels, batteries and controllers. If you've not seen those, look back at the previous 4 videos. And today we're going to cover lighting. So 12-volt lighting. Lighting is one of the simplest upgrades you can make to an off-grid vehicle or home. Modern LED lights use very little electricity, produce almost no heat, and often last for tens of thousands of hours. Always make sure you buy lights designed for 12-volt DC automotive, or caravan or marine systems, as a battery actually varies between 12 volts when discharged and about 14.6 volts whilst charging. So you're better off getting automotive kit. You can also choose different colour temperatures depending on the atmosphere you want. Warm light creates a cosy feel, neutral light is good all-round choice, while cool light is used for workshops or detailed jobs. So planning your lighting. So before you start drilling holes or pulling cables, think about how you'll actually use the space. And there's an example in the picture of where you've got a living area, a kitchen area and a bed area. And you can draw that all out. It doesn't take too long. Bugger off, right? Rather than fitting one bright light in the middle of the ceiling, which I tend to do anyway, just so you can have that bright light. But then I don't use that. I use the smaller lights. Divide the vehicle into zones such as the living area, kitchen, bedroom and outside light. Strip lighting under cupboards or around the ceiling often gives a softer, more even light than a single fitting, and separate switches mean you illuminate the areas you're using, saving battery power and making the whole system more practical. So wiring safely. So lighting circuits carry relatively little current, so it makes them one of the easiest electrical jobs to tackle, and it's very you're unlikely to get a shock off a lighting circuit. So using standard automotive cable because it withstands vibration much better than household wiring. It's also cheaper as well. For most installations, 1.5 square millimeter cable is ideal. Keep the cables as short as practical to reduce voltage drop, and secure them properly as they cannot rub against metal and sharp edges, etc. Stick to the standard colour coding of red for positive and black for negative to make future maintenance much easier. Although if you're maintaining or doing up some older systems, you may find you've got slightly different colours. But if you can change over to black and red, that's better. So fuses and switches. So every lighting circuit should have its own fuse, positioned as close to the battery or if you've got a separate fuse box as possible. The important thing to remember is that the fuse protects the cable, as we said last time, not the light fitting itself. If a cable becomes damaged and shorts out, the fuse disconnects the power before the wiring overheats. And most lighting circuits only need 3 to 5 amp fuses. The good quality rocker or toggle switches work well. LED dimmers can make the living space much more comfortable during the evening. So we're going to go for an example here just to work out how much power you need. So one of the most common mistakes in DIY solar systems using using cables that are too small or fuses that are too large. So here you can see an example of how to work out what power you need. So you've got 4 times LED lights, so that comes to, and they're usually about 3 watts each. So the total power is 4 times 3 is 12 watts. And let's say you're going to use them for 5 hours in the evening. Obviously, it's a hell of a lot less at the moment. In fact, I don't have any lights on in the evening at the moment. Used for say 5 hours in winter. So it's 12 times 5 equals 60 watt hours. Considering your battery use, you divide that by the 12 because it's a 12 volt battery, so it gives you a 5 amp hours. So only around 5 amp hours per evening, that's all you're using. So good electrical practice. Most electrical problems come from poor connections rather than faulty equipment. So use a proper ratchet crimping tool and quality terminals rather than simply twisting wires together. And that's also can be quite dangerous, especially if you've not got things fused. I've known people lose their home because they've got shitty wiring. They just crimp it. They're just twisting things together and hoping for the best. And it's really not that hard to do if you get the right kit. It's all cheap on Amazon these days. So waterproof any external connections with heat shrink tubing or waterproof connectors. Test every circuit before permanently fixing it in place, and label cables if you're installing several lighting zones. Why not? A tidy electrical installation is much easier to maintain and much safer over the long term. So installing 12 volt lighting is one of the easiest off-grid electrical projects you can do. Almost anyone can do that. Plan where you want the light before wiring anything. Use proper automotive cable. Fit the correct fuse close to the battery and make good electrical connections. LED lights consume very little power, so a well-designed lighting system will provide years of reliable service while placing hardly any demand on your batteries. So I can't even, I don't even notice when I use my LED lighting system. It doesn't, it's in the noise almost. It has almost no effect on my batteries whatsoever. Once you've got the lighting sorted, your off-grid home becomes far more comfortable, practical and enjoyable to live in. So next we'll explore modern power stations such as Bluettis, Jackeries and EcoFlows. A few people have asked about those recently, and discuss where they make sense and where a traditional solar installation may be a better option. We'll also cover some of the most common mistakes people make when building solar systems, along with the safety issues that can turn a simple project into an expensive and dangerous one. Finally, we'll look at how to expand your system over time, and I'll do that using my own system. So I'll tell you how I expanded over the years, adding more panels, more battery capacity and additional equipment as your needs grow, including how and when to connect panels in series or parallel. And I'll cover that again. I've got two sets of 3 panels connected in series, both connected in parallel. There you go. The goal isn't to build the biggest system possible, it's to build the right system for the way you actually live. Then after that, who knows? I'm not sure yet. I'll either do heating, although that's somewhat irrelevant at the moment, or we might just go on to how to use gas safely, etc., gas appliances, etc. So I'll let you know next video what I'm going to cover next. So until next time, stay safe, stay curious, and enjoy the freedom that comes with generating your own power. So yeah, there's the things we're going to cover. So thanks for watching. See you in part 6. Again, if you can leave comments, etc., it does get it helps to get the message out there. So stay well, stay safe, and fuck the system.